Hello! In today's tutorial, we will be covering how to add a multi-camera setup to your custom VTubing application using the Unity package Cinemachine. At the end of the tutorial, as a bonus, I will show you how to integrate your camera system with an external application like SAMMI, Touch Portal, or Stream Deck. Let's begin. The first thing you will want to do is to create a parent object for your avatar. Locate your avatar in your scene hierarchy, right-click, and choose Create Empty Parent. Next, you'll want to make sure all transforms on your avatar are zeroed out. If any are not zero, copy and paste them to your parent. Next, drag any objects that you want to move with your avatar into the model holder. Here, I have moved the dropper and the thrower into the model holder so that no matter where we move the model, we can still drop and throw items at it. This is all the preparation we will need to teleport our model throughout our scene. Next, you will want to add the Cinemachine Unity package. Go to Window, Package Manager. For packages, make sure to select Unity Registry and locate the Cinemachine package. Click Install. Once the Cinemachine Unity package is finished installing, you can begin adding your individual camera shots. I like to start by adding an empty and zeroing it out. This will serve as a logical container for our individual shots. If you already have the main camera located in the scene somewhere where you would like to keep it, first start by selecting your main camera, right-clicking Transform, copy, World Transform, as placing a virtual camera will move your main camera. Next, right-click your camera's object, select Cinemachine, Virtual Camera. This will be your first shot. If you copied your main camera's location in the previous step, you can right-click Transform, Paste, World Transform, and this will place the camera where you had it previously. Please note that adding a virtual camera automatically adds the Cinemachine component to your camera. I will explain this component later in the tutorial. You can now place as many cameras as you would like. As a tip for placing cameras, you can take your Game tab, drag it, and dock it alongside your scene view. Now, as you position your camera, make sure it is the only active camera, and you will see where it is being placed in the final render. I have also prepared a face cam that resides inside the model holder. As a part of this face cam, I have set the look at target to the head bone of my model. This is an optional step to keep your head centered in the camera. You may now create the visual script to control your camera objects. Select the camera's game object, add component, script machine. Click New, and give it a name. Click Edit Graph. You may remove the pre-generated nodes. Next, you will want to create an object variable. Here, I have named it Cameras of type List of Game Object and added the virtual cameras from our scene to the list. We will begin our graph with a custom event. I will give this event the name Camera Change and set the number of arguments to 1. Argument 0 will be an integer or number that represents the camera's location in the list. Keep in mind that computers start counting from 0. So our cameras will be 0, 1, 2. Add the cameras variable to the graph. Continuing from our custom event, we will add a for each loop. We will then assign our camera's variable to the list. For the body of our loop, we will use setActive. We will assign the item to the first port and leave value unchecked to set the game object to inactive. What this will do is loop through all of our virtual cameras and turn them off so that we may turn on the one that we wish to have set active. Next, from our camera's variable, we will get item. Using arg0 for index. Continuing from exit, we will create another setActive. We will then connect the output of getItem to the first port, and then check value. This will set the game object to active. I will now create some on-keyboard events to control our camera system. This on-keyboard event will trigger the camera change to change it to camera 1, remembering the computers count from 0, so that will be big screen in our list. As a tip for creating additional keyboard events, you can select all the nodes and press Ctrl D. This will duplicate your nodes and you can change the values as you need. With the desired keyboard inputs created, you are now ready to run your application. If you wish to alter the speed at which it transitions between cameras, you can do so by selecting your main camera and locating the CinemachineBrain component. Locating the default blend, you may change the easing and set the number of seconds that it takes to transition. If you want to override the blends for a single camera, locate Custom Blends and click Create Asset. Click Add. Here you can select the From camera, the To camera, the easing style, and the time to complete the transition. Running the application, you can check your values. Now we will create the teleport system to move your character when the camera changes. In your hierarchy, right-click and create empty, and zero out the values. This will serve as a logical container for our individual teleport locations. Right-click the teleports object and create empty. Place this object in the scene where you would like your model to stand. Since my model is already standing where I want it to be for this teleport, I will select my model, right-click, copy, world transform, and then paste that transform into my teleport. You may create as many teleports as you would like. As a tip, dock your game view again, set the desired camera to active, place your model where you would like it to be, and then copy its transform to the desired teleport. To add our teleport logic, return to our cameras and select Edit Graph. Here I've added two new variables: teleports of type list of game object and model of type game object. This is very important. Teleports will have to contain the same number of values as cameras. For any camera where you do not wish for the model to teleport, leave that index as none. These will be mapped 1 to 1, meaning the first item in your cameras list will be mapped to the first item in your teleports list, and so on and so forth. The value of model will be your model holder from your game hierarchy. Continuing from our previous setActive node, you'll do null check. Add your teleports variable. From that, we will get item. And pass in arg0 for the index. Then connect the output of get item to the input of null check. Add your model variable to your graph. And then from not null, set position of the type transform. Connect the output of your model variable to the first port, and then from your get item, get position. Connect the output of get position to the second port, continuing the flow from set position, set rotation. Again, connect your model variable to the first port, and then from your get item, get rotation, and connect that to the second port. You may now run your application. As an added bonus, let's add a Web API endpoint so we can control the current camera from an external application like SAMMI, Touch Portal, or Stream Deck. In your project hierarchy, locate your Web API, right-click and edit your API controller. Next, add two fields. The first being a camera queue and a reference to our camera's visual script. Next, we will add the required logic to our update function. Here we are creating a local variable to contain the current camera. We're getting the next camera from the queue and triggering the custom camera change event in our visual script. Next, we will create our API endpoint for our external application. Here we have created the endpoint cam change, which receives the camera index that we wish to change to. It then adds that camera to the camera queue to be processed by our update method. You may save your script and return to Unity. If your script was successful, you should see the cameras property on your API controller. Drag the cameras object into that property. Now to configure your external application. For this, I will use SAMMI. Select your desired button and choose Add. Select Utilities, HTTP Request. For URL, enter the URL to your API, passing in the cam that you wish to switch to. This will be the value of arg0 in your visual script. For method, select Get. Click OK and save. Returning to Unity, execute your application. When you click the buttons, your camera should change. This concludes this tutorial. I hope you have found it helpful. Please like and follow if you would like to see this series continued. Leave a comment below about what you would like to see in future tutorials. I hope you have a wonderful day, and I will see you next time.